Okay, so for a lot of problems, we're going to ask you what the roots of the equations are. And here, my general advice is to use this number here, the C value, 21, and look for factors of 21 that add up to your B term, negative 10. So what factors of 21 add up to negative 10? Well, negative 3 times negative 7, that's positive 21, right? And if we add negative 3 and negative 7, that equals negative 10, so that's it. If we factor this out, we would get x minus 3, or x plus negative 3, times x plus negative 7, or x minus 7. And what factored form allows you to do is to realize that you're multiplying two numbers that equal 0. One or the other has to be 0. So if x minus 3 equals 0, the first term here, solve for x, and x equals 3. That's your first root. If x minus 7 equals 0, solve for x, and x equals 7, that's your second root. So 3 and 7, choice 3. You can also plug these values in to check, or you can just do that to begin with. If you plug in 3 or 7 into this formula, you will get 0. So those are the roots. On the graphing calculator, you can do this as well. You can enter in, we'll clear this off, x squared minus 10x plus 21, right? And then graph it. And here, if you want to find the roots, you hit second trace, and you want to find the zeros here. So you tell it, right, zeros are the roots, because the zeros are when you cross the x-axis. So here, let me just find the cursor. There it is. It'll ask you for a left bound, okay, and then a right bound. So left and right side of the parabola crossing the x-axis. It will guess. Sometimes it'll be approximate, but here you can see when x is 3, y is 0. And then you can repeat that process again over here. Second trace. You want to hit 0, okay. Scroll to the right. It's asking you for a left bound. This time we're zooming in over here, so enter, and then to the right of that, enter. To ask you to guess, yes, so 7. It can find the roots as well. So that's 3 ways to solve that problem. What are the vertex and axis of symmetry of this parabola? X squared minus 16x plus 63. Okay, well, the axis of symmetry, and this is a formula that you will need, is always equal to negative b over 2a. So what's our b term here? Our b term is negative 16. So negative b is positive 16 over 2a. A is just 1. It's not written here, but it's 1. So it's 2. 2 times 1 or 2. And that's 8. So the axis of symmetry is for x equals 8, not negative 8. Right? So these two cancel out. And the reason it's x equals is because if you think of this parabola, right, it's kind of like this, let's say. The axis of symmetry is here. It's a vertical line where x equals 8. That's what it's saying. Now the vertex will have to have the same x value because the axis crosses the parabola at x equals 8. So you plug 8 into your formula and you'll get the complete point. That's all there is to this. So y equals x squared, so 64 minus 16 times x, or minus 16 times 8, plus 63. So now when you set this up, 16 times 8, right? That's 64 minus 16 times 8. That's, well, 80 and 48 is 128 plus 63. I think of this as all addition, so it's 64 plus a negative 128. I like doing that because with addition you can rearrange. So 64 and 63, that's 127 minus 128, that's negative 1. Okay, so the answer is 1. Vertex of 8, negative 1. What are the roots of this equation? Well, just, we're looking for factors of 6, that add up to negative 7. So I know that negative 1 times negative 6 is equal to positive 6. They multiply them, we get 6. And if we add them, we get negative 7. So those are our roots, almost, right? This allows us to get us into factored form. X minus 1 times x minus 6 equals 0. And this is nice because now the product of these two numbers is 0. So one or other, or both of them are 0. If x minus 1 is 0, x equals 1. If x minus 6 equals 0, x minus 6, and those are your two roots. What's really nice about this process, you'll notice, if we find it to be x minus 1 and minus 6, then our roots are plus 1 and plus 6. Those are always opposites. So you can almost cut out this middle step. So here, our choice answer is 4. Which expression is equivalent to 121 minus x squared? So 121 minus x squared, that's the difference of two squares, right? 11 squared is 121, and x squared is equal to x squared. And this is always equal to, in this form, 11 minus x times 11 plus x. There's always this alternate switching of the operations, so you can quickly find the way to factor this by looking at the difference of squares, where if you have, let's say, a squared minus b squared, that's always equal to a minus b times a plus b. That just means a squared, we'll take the square root of that, that's your first term. So we had 121, square root was 11. Second term is b squared, take the square root of that. Our b squared term is x squared, so b is just x, right? And we put those terms there. And it's minus plus, and that's all there is to it. You can cross out choice 1, it's minus minus. Same thing with choice 4. And the remaining 2, it's not going to be x plus 11 times x minus 11, right? That would give us negative 121. It's, in fact, choice 3. And you can test those by using the distributive property. Okay, so we're given the graph of minus x squared minus c. And they're saying, what's the graph of x squared minus c? Well, you can play out this with the graphing calculator, actually enter in c values to see what makes the most sense. But here, what I would think about is that inverting the a value would change the direction. So instead of having our parabola where it is right now, when we go from the whatever it's at to the new form, it will be the, almost I could say, the upside down of that, right? Oops, that was terrible. Like this. Right, it'll be essentially the exact same thing, but flipped upside down. And you can verify this in your graphing calculator. Press the y equals button, negative x squared, and then minus c. That'll give us a c, so I'll just choose 1. I'll make it more dramatic, let's say 5. And then the inverse of negative x squared, or the opposite, excuse me, of negative x squared. So x squared, right? And then keep the c value the same, so minus 5. Enter, and then graph it. You can see it right there. The height y of a ball is tossed in the air. And tossed into the air can be represented by this formula, where x is the time. What is the equation for the axis of symmetry? Axis of symmetry is the line that folds your parabola in half. So if a parabola is like this, the axis of symmetry will go here through the vertex. Well, this always ends up equaling negative b over 2a. So just identify the fact that 10 is b, so it's negative 10 over 2a. 2a here is just negative 1, so it's over 2 times negative 1. So negative 10 over negative 2 is equal to 5. So x equals 5. And the reason it's x equals 5 is because this is a vertical line, not a horizontal line. What are the roots of this equation? Well, the first thing I would do is get all these numbers on one side. So if x squared equals 30 minus 13x, so we're going to add 13x to both sides, and we're almost there. Then I have x squared plus 13x equals 30. And then I subtract 30 from both sides. And now I'm ready to factor x squared plus 13x minus 30 equals 0. When it's equal to 0, you can quickly find the roots. Remember, the roots are when this quadratic equals 0. So that helps us, right? X squared plus 13x minus 30. So what are the factors of negative 30 that add to positive 13? Right, that's our goal here. So I would choose, I'm going to say that if you take positive 15 times negative 2, that gets you negative 30. But if you add these two, 15 plus negative 2, what do you get? Well, that's just 13. So that means you can factor this into x plus 15 times x minus 2 equals 0. Now, if this equals 0, then either x plus 15 equals 0, x minus 2 equals 0, or they both equal 0. So x plus 15 equals 0, and x minus 2 equals 0. Solve for x, add 2 to both sides here. X equals 2, that's our first root. Subtract 15 from both sides, so x is negative 15, and that's our second root. Okay, so somebody named Han correctly factors an expression that has a difference of two squares. Which one could be her answer? Well, a squared minus b squared, difference of two squares, always equals a plus b times a minus b. So the first thing you should notice is that you need these alternating signs here. So out of these choices, we can automatically cross off 4 and 3. They're minus minus, and that can't happen. The next thing is that you notice that the a term is repeated, and so is the b term. So here, these two, out of these two, choice 1 can't be it, because here we have 2x and there we have x. So the only one that actually follows this form is choice 2, where we have 2x and 2x, 3y and 3y, and plus minus. If that happens and you distribute, you will get the difference of two perfect squares. Find the roots of this algebraically. Okay. So x squared minus x equals 6. So we subtract 6 from both sides. We want to get this equal to 0. And 0 equals x squared minus x minus 6. So in general, when you're finding the roots, the next step is to factor. And all you have to do to factor is find numbers that multiply to this term that add up to negative 1. Or negative b. Excuse me. Forget I said that. That add up to b. In this case, b is negative 1, right? Because we have negative x. So what factors of negative 6 add up to negative 1? Well, if I take negative 3 and multiply that by 2, I get negative 6. And if I add negative 3 and 2, I get negative 1. So those are my factors. So I can factor this into x minus 3 times x plus 2, and that will equal 0. I'm just factoring this form out here. And if this is true, then we can assume that x minus 3 could be 0, and x plus 2 could also equal 0. Right? Because if you're multiplying two numbers to get 0, this is your first number, and this is your second. If you're getting 0, then one of the numbers or both of the numbers is 0. Solve for x, add 3 to both sides. So x equals 3, that's our first root. And subtract 2 from both sides, and x equals negative 2, our second root. What are the roots of this equation? So again, the strategy you're going to be using in most of these level problems is to find factors of the c term, that's this term, that add up to your b term. So in this case, what factors of 6 add up to negative 5? Well, don't forget that negative 2 times negative 3, that equals positive 6. And if we add negative 2 and negative 3, we get negative 5. So if this is true, then we can factor it into x minus 2 times x minus 3. That will equal 0, so this number or both equals 0. And to solve it, we set both equal to 0. So x minus 2 equals 0, x minus 3 equals 0. Add 2 to both sides here. Add 3 to both sides here. So x equals 3, and x equals 2. And those are our roots, 2 and 3. Choice 2. What is the equation for the axis of symmetry of this parabola? Well, the axis of symmetry always equals negative b over 2a. And we're given equations where y equals ax squared plus bx plus c, or we have to manipulate them to get them in that form. But once we have them, the b term is right next to the x, and the a term is right next to the a squared. So in our case, b equals 6, right? b equals 6. And a equals, well, we have negative x squared, so a equals negative 1. So that means negative b over 2a, that's negative 6 over 2 times negative 1, or negative 6 over negative 2, which is positive 3, and it's x equals 3. The reason we have x equals, right, remember this is a parabola, so here, here's something like this, a parabola is at this value here, and this red line would be our axis of symmetry. It's just a vertical line, and those vertical lines are of the form x equals a number. Choice 1. So which equation has these two numbers as roots? Well, if we plug them in, we'll know if they're roots, because if we plug this in, we should get 0. If we plug both roots in, they both get 0, then they're both the roots for that equation. So the first one we have x squared, so negative 3 squared plus 2 times negative 3 minus 15. Well, it's 9 plus negative 6, so minus 6 minus 15. That's not 0, so that's not a root. And the next one, x squared, so we have 9 minus, 2 times negative 3, so it's plus 6 minus 15. That does equal 0. Now we plug in 5. 5 squared, 25, minus 10 minus 15. That also equals 0, so the answer is 2. So just by plugging those numbers in to see if we actually do get 0, you'll know that they're the roots. Okay, the graph of a parabola is represented by y equals ax squared, where a is positive. If a is multiplied by 2, how will the new parabola look? They're basically asking us, how does it change based on the a value? Well, this is your a value here. If it's positive, right, and you multiply it by a higher value, or a is greater than 1, what will happen is this will become a steeper parabola. So for example here, let me clear these off. If I have y equals 1x squared, and then I have y equals 2x squared, notice how it's kind of centered at the same vertex, but it's much steeper because the rate of change is greater. And this is exactly how it always works, whether a is positive or negative. As long as a, when you multiply it by its new value, is something larger than 1, it will become steeper, right? Steeper like this. And if it's a fraction, it'll become a wider parabola because the rate of change will be slower. So it should be narrower and open, well, so it's still, okay, so positive, if a is positive, it opens upwards. If a is negative, it would open downward. So when you multiply a positive by a, where a is, multiplied by another positive 2, it still opens upward, but steeper. So it's opening upward and steeper. Narrower and opening downward would be if, let's say, you're multiplying by negative 2. Wider and opening downward would be multiplying by, let's say, negative 1/2, some fraction between 0 and 1. And wider and opening upward would be multiplying by positive 1/2. Sorry, opening downward would be negative 1/2. Opening upward would be positive 1/2. The idea is if you multiply by an a value that's between 0 and 1, the rate of change is slower and they're wider parabolas. This expression is equivalent to which of the following? Well, this is a classic difference of two squares problem, where, with difference of two squares, if you haven't seen that before, let's say you have a squared minus b squared. It's a difference of two squares because you're subtracting. And then it always ends up equaling the square root of a squared, which is just going to be a, minus the square root of b squared, and then a plus b, just like that. So here we have 64 minus x squared. Well, that's going to be 8, which is the square root of 64, minus x times 8 plus x, right? Or choice 2. What is the equation for the axis of symmetry here? Well, the axis of symmetry equals negative b over 2a. And here, this is our a term. This is our b term. B is equal to negative 3. So we have negative 3 over 2 times 2, which is negative 3/4. Here, though, if I see, I apologize. It's not. Since b is already negative 3, we have negative b. It's negative 3, or positive 3. Sorry about that. It's positive 3/4.
And that's choice A. X equals 3/4. X, since it's a vertical line for the axis of symmetry. It would be y equals 3/4 if you had a horizontal line. Thanks.
What are the roots of this equation? Well, they want to know, what values of x get us 0. That's what a root is. So here, we have 3x squared minus 27x equals 0. So what's the common factor here? Well, these both have 3x in common, so 3x times x would be 3x squared minus 9 equals 0. So 3x could equal 0, as one of the numbers are multiplying here to get 0, or x minus 9 could equal 0. If 3x is 0, divide both sides by 3, and x is equal to 0. If x minus 9 equals 0, add 9 to both sides, and x equals 9. Those are our two roots, 0 and 9. And you can just plug them in and see if they work. If you plug in these numbers and you get 0 for both, then they're both roots. What is the product of 3x plus 2 times x minus 7? Well, here we just use the distributive property. 3x times x, that's 3x squared. 3x times negative 7, that's negative 21x. 2 times x is 2x. And 2 times negative 7 is negative 14. Simplify these two. What's negative 21 plus 2? That's negative 19x. So we have 3x squared minus 19 minus 14. That's choice 3. What is the vertex of this parabola? Well, the vertex of the parabola is based on the axis of symmetry. So let's find that first. So the axis of symmetry is negative b over 2a. B is always equal to this number next to x, so it's negative 24. A is this number next to x squared, so that's 2 times negative 2. So we have negative 24 divided by negative 4, which is positive 6. So that means x equals 6, right? The axis of symmetry is the vertical line, right? If we have a parabola, let's say like this, right? Or wherever it is, our vertical line cutting through it here, x equals 6, is the line of symmetry, or axis of symmetry. But now we want to find the vertex, which is where the axis of symmetry crosses your parabola. So let's see how off my graph is, because let's see where the vertex is. All you have to do then is plug in x equals 6 into your equation. So y equals negative 2 times 6 squared plus 24 times 6 minus 100. So 6 squared is 36 times negative 2 is negative 72. 24 times 6, that's 144. So plus 144 minus 100. So this is what y equals. So we can solve this quickly on our graphing calculator, right? Negative 72 plus 144 plus 144 minus 100. That's negative 28. So our point here is 6, negative 28. All right, maybe it wasn't that bad in my drawing. I guess we could scale that as about negative 28 there. Okay, which equation represents a quadratic function? Well, that's 3. Because if you take a variable raised to the second power, that's what quadratic is. This is an exponential function. This is the absolute value function. And this is linear, in case they ask you. Here, we've got two graphs, x squared and negative 3x squared. How do they compare? Well, when y equals x squared, you have a parabola like this, opening upwards because the a value is positive. A is the number multiplied by x squared. Dave's graph has negative 3x squared, so it will be steeper and going downward. Right? A negative parabola opens downward, and because this number, the absolute value of this number, is larger than 1, which is what it is here, it's steeper, right? So it's negative and steeper. So Dave's graph is not wider, it's narrower and opens in the opposite direction, choice 2. Thank you.